to mix a solute into a solvent, then you will get a solution. Then you will get a solution. Now see, how will you recognize whether which one is solute and which one is solvent? So it's very easy. The one with lesser in quantity and the one with greater in quantity. The one with greater in quantity is solvent and the one with lesser in quantity is solute. Lesser in quantity solute and solvent and greater in quantity solvent. If you're going to mix them, you will get a solution. Now problem is, no. In our syllabus, we only need to study about the binary solution. Binary solution. That means a solution which contains two particles. That means basically in a solution there can be more than two particles, but in our syllabus we need to study only about binary solution. We need to study only about binary solution. That means a solution in which only two particles present, one is solute and another is solvent. That is called binary solution, and this is in our syllabus. Please do write it and then let me know. Are you done with this? Sakina, are you done with this?
Yes, sir.
Okay. Now see, the next topic, which is very important, you have already studied about this in class 11th, and that is concentration term. Concentration terms. So now concentration terms are of two types. We can divide it into two types. The one which is temperature dependent, the one which is temperature dependent, and the one which is temperature independent. Temperature independent. So how we are gonna recognize whether which one is temperature dependent and whether which one is temperature independent? So you have studied that volume is directly proportional to temperature. That means the concentration term which has volume in their expression, that will be dependent on volume. Indirectly, it will be dependent on temperature. Is that clear to both of you? What I want to say is that volume directly proportional to temperature. That means in concentration term, in any of the concentration term, if volume is present in the expression, that means it depends upon the volume. Indirectly, it also depends upon temperature. So I'm going to give you this weight by volume percent. Volume, you can see there is volume by volume percent. Then there will be molarity. Then there will be normality. These all are basically temperature dependent, because in this all concentration term, these all are concentration term which has volume in their expression. Now temperature independent, that is mole fraction. You can also write the next one is weight by weight percent. The next one is molality. What we can write? Molality. So please do write the name of all this concentration term. Let me know when you are done with this.
Yes, sir, done.
Very good. Now see, I'm going to start from this, this, and this one is just first. Then we will move to the next. So you can see the first I'm going to introduce is your weight by weight percent. Always remember that the one which is in numerator is for solute, and the one which is on denominator is for solution. And since it is weight, so we will take it in gram. Since it is weight, we will take it in gram. If it is in volume, then we will take it in ml. Now, if it is given like 10% weight by weight, what does this mean? So we can extract a whole sentence from this small words, that is 10%. That means you are going to take 10. And since it is W here, that's like 10 gram of, you can see this W is for solute. So 10 gram of solute present in, you can see there is percent. That means percent means 100. And in denominator, you can see W weight. So 10 gram of solute present in 100 gram of solution. This means that This represents that 10 gram of solute present in 100 gram of solution. So from here we can see that the mass of solute is 10 gram and mass of solution is 100 gram. If I am going to give you, Sakina, 5% weight by weight, what does this means? Can you extract information about this?
Sir, 5 gram of solute
Yes,
present in 500 gram of solution.
not 500.
100.
Percent is only for 100, so it will be for 100 gram of solution. Are you getting my point? So you
Yes,
can
sir.
easily, can you tell me what will be the mass of solvent from this information? If you know the mass of solute, mass of this is your gram of solute, right? And this is your present in 100 gram of solution, right? So can you extract or can you find the mass of solvent from this information?
Sir, I don't know.
Okay, you know that solute plus solvent. If you are going to add solute into solvent, you will be getting solution,
Solution. Yes, sir.
right? So, what is the value of solute? You know that this is your 5 gram and this is your mass of solvent. So, and this is your 100 gram. So, mass of solvent is 100 minus 5, that will be 95 gram. Are you getting my point?
Yes, sir.
Very good. Please do write it. Let me know when you are done with this.
Sir, done.
Very good. Now I'm going to write a formula for this, and that is weight by weight percent is equal to weight of solute upon weight of solution into 100. This is the formula. Okay. Now I'm going to give you a question. 10 gram of A mixed in 100 gram of B. Calculate weight by weight percent. Will you be able to solve it? Yes or no?
Sir, 100 gram is the solute or the solvent?
Tell me if you're going to have this solution, sugar solution. Can you tell me which one is solute and which one is solvent?
Sir, sugar is the solute.
And water is?
Water is solvent
Why you took sugar as a solute?
because it is less in number than the water.
Why are you saying that 100 gram is solute? Isn't it greater? 10 gram is age solute, no? The one which is lesser in quantity is solute, and the one which is greater in quantity is solvent.
Yes, sir. So the answer will be 10.
No. If you are going to mix solute plus solvent, then you will get solution. Yes or no? Tell me.
Yes, sir.
Now you can see that this is your 10 gram and this is your 100 gram. So the mass of solution will be 110 gram. Now going to apply the formula. Weight by weight percent formula. What is the formula? What does this formula says? Weight of solute, that is 10 gram. Weight of solution, what is the weight of solution? It will be 110 gram and 200. 9.09% something. Are you getting my point? Yes or no?
Yes, sir.
Please do write it and then let me know. Are you done with this?
Yes, sir.
Okay. Now moving to the next, that is your weight by volume percent. Now again, you know the concept behind it. This is for solute, this is for solution. Now if it is given that 5% weight by volume, then it will be 5 gram of solute present in, since it is percent, that means 100, and since it is volume, so we will use 100 ml of solution. Is that clear? If I'm going
Yes,
to ask
sir.
you 10% weight by volume, what does this mean? Can you tell me?
Sir, 10 gram of solute
Yeah,
present in 100 ml of solution.
very good. Now we can have a formula for weight by volume percent. Weight of solute, and in denominator you can see this is your solvent solution. So it will be volume of solution into 100. So I'm going to give you you can see that if I will give you 10% weight by volume NaCl, then NaCl in a solution of density 1 gram per n, calculate weight by weight percent. Let me know if you are not able to solve it.
Sir, I can't understand the question.
Okay, see. NaCl present in a solution which has a density 1 gram per ml, and this is also given. Whenever this type of expression is given, you are going to extract information from this. And you know what does this stand for? It will be 10 gram of solute. That means here the solute is NaCl present in present in 100 ml of solution. Yes or no? It means this, Sakina.
Yes, sir.
Now it is also given that density of solution is 1 gram per ml. Density of solution is 1 gram per ml. Now, what we need to calculate weight by weight percent, and what is the formula for weight by weight percent? Weight of solute upon weight of solution, weight of solute upon weight of solution into 100 into 100. Now you can see that this is the formula that we need to apply because we need to calculate this. Now in the formula you can see weight of solute. We have to put it here. Now weight of solute is given as 10 gram. Yes or no? It is given as 10 gram. And weight of solution we need to apply. We need to put it here. But in the question it is not given directly. Volume of solution is given and density of solution is given instead of weight of solution. So we know the formula density is equal to mass upon volume. So mass of solution will be equal to density of solution into volume of solution. So density of solution is 1 gram per ml and volume of solution is 100 ml. So ml and ml will be cancelled, and now the mass of solution is 100 gram. So 100 gram of the solution and 100 is in the formula here. So you can cancel this and you will get 10% weight by weight. So whenever you are going to do any type of question, what you need to do, just extract and see whatever is given, just focus on that and then write the formula of the quantity that has been asked and then think about it from where you can get this quantities and you can easily do this. Isn't it easy? Sakina, this is given, and this is what we needed to calculate. So I wrote the formula of this, and you can see in numerator we need to you need to put the we need to put the value of weight of solute that is given, and in numerator denominator you can see weight of solution which is not given. But for weight of solution we can easily calculate from the given information, that is volume of solution and density of solution. And you know the formula for density, right?
Yes, sir.
Please do write it and then let me.
Sir, done.
Very good. Now I'm going to change the slide. Ten percent weight by weight to be present in a solution of density 1.25 gram per ml. Calculate weight by volume percent. Please do it in step words. Let me know when you are done with this.
Sir, done.
What is the answer that you have got?
Sir, 12.
Well, that's good. Alan, let me just check what you have taken from here. It is 10 gram of sugar, that means basically solute, present in 100 gram of solution. 100 gram of solution. Density is basically 1.25 gram per ml. Now, Yeah, so 100 gram. Okay. Now we need to calculate weight by volume percent, and weight by volume percent is weight of solute upon volume of solution into 100. Now weight of solute you can directly see it is 10 gram. So I just put it 10. But volume of solution is not directly given, but we can calculate with the help of mass of solution and density of solution. So you know that density of solution is equal to mass of solution upon volume of solution. Now you can see volume of solution is equal to mass of solution upon density of solution. Mass of solution is 100 gram and density of solution is 1.25 gram per ml. This ml will move to the numerator. So 100 divided by 1.25, that will give you 80 ml. So I'm going to put the value of volume of solution as 80, and then 100 it will be 0, 0 will be cancelled, and then 100 divided by 8, that is equal to 12.5% weight by volume, not 12, right? Sakina, where you have mistaken.
Sir, I did calculation mistake.
Okay, so let me know when you are done with this. And then we will move to the next concentration term. Are you done with this?
Yes, sir.
Okay. Now moving to the next concentration term, that is mole fraction, and it is denoted by this X type term that is known as chi. Now see, what is this mole fraction? In a container, if you have two component present in this, A and B, A has a number of moles Na and B has a number of moles Nb. Now can you tell me the how what is the formula for number of moles? What is the formula for the calculation of number of moles? Can you tell me?
Sir, can you repeat what you said?
Number of moles formula. Formula for number of moles.
Oh, I don't know, sir.
Okay. Wait a minute. Now see. Number of moles formula is basically the most used is basically given mass upon molar mass. Given mass upon molar mass. Another formula for number of moles is given volume upon molar volume. Given volume upon molar volume. And molar volume has a value that is 22.4 liter. Number of moles is equal to given number of particle upon Avogadro number. Upon Avogadro number. You know the value of Avogadro number, yes or no? Na, that is equal to 6.022 into 10 raised to the power 23. And can you calculate the value of molar mass? Yes or no? So you have three different formulas for calculating number of moles, and this is given mass upon molar mass, given volume upon molar volume, that is 22.4 liter, given number of particle upon Avogadro number, that is 6.022 into 10 raised to the power 23, and the most used for this concept is given mass upon molar mass. Is that clear?
Yes, sir.
Sakina, Sakina, do you know how to calculate molar mass? Yes or no?
Sir, do we calculate the molar mass with the molecule atomic mass?
Yeah, it is. Uh, just uh,
Yes, sir. Then I know.
just tell me what is the molar mass of H2SO4? Just try, give it a try. What is the molar mass of H2SO4?
Sir, I'll just do it and tell.
Okay.
Sir, 98.
Very good. That means you know how to calculate. Okay. Moving to this part, mole fraction. So in this container, you have two quantity A and B. So in order to calculate mole fraction of A, that means chi A, this will be equal to number of moles of A upon total number of moles in the container. That means number of moles of A plus number of moles of B. Again, if you are going to calculate mole fraction of B, that means chi B, that will be equal to mole fraction of B in numerator and total number of moles in denominator. So this is the formula for calculating mole fraction. Please do write it. Are you done with this, Sakina?
Yes, sir.
Okay, I'm going to give you a question on this. 46 gram of C2H5OH presenting 72 gram of H2O. Calculate mole fraction of each component. Calculate mole fraction of each component. Let me know when you're done with this or if you have any doubt.
Sir, I can't do it.
Okay, so see, it's very easy. What do you need to do? 46 gram of C2H5OH present in 72 gram of H2O. Calculate mole fraction of each component. So if you are going to, you have two components, C2H5OH, that I'm going to take it as, okay. So if you are going to apply the formula for C2H5OH, it will have a formula, number of moles of C2H5OH upon number of moles of C2H5OH. And what is the another component? That is number of moles of H2O. Is that clear? Yes or no?
Yes, sir.
Now, mass is given and we need to put the value of number of moles. So we will calculate number of moles of C2H5OH, which has a formula given mass upon molar mass. What is the given mass? 46 gram. Can you calculate the molar mass of this C2H5OH? Please do calculate it.
Sir, 46.
46. Very good. So it will be 1 mole. Now we also need to calculate number of moles of H2O. So number of moles of H2O is also given mass upon molar mass. Given mass is 72 gram. Can you calculate the molar mass of H2O? Please do it.
18.
80. So if you are going to calculate it, it will give you what 4 moles. Now going to put the value only. Here it will be 1 upon 1 plus 4. That will be equal to 1 by 5 mole fraction. And if you are going to calculate the mole fraction of H2O, it will have a formula. Number of moles of water upon number of moles of water plus number of moles of C2H5OH. Now you already had calculated the number of moles of H2O, that is 4. Again H2O plus number of moles of C2H5OH, that is 1. So it will give you 4 by 5. Are you getting my point? This mole fraction is unitless. This mole fraction is unitless because you can see in numerator you have mole and in denominator you have mole, so it will be cancelled. Okay.
Sir, done.
Very good. Now I'm going to give you another question on this. That is 80 gram of NaOH present in 36 gram of H2O. Calculate mole fraction of each component. Calculate mole fraction of each component.
Sir, will it be 2.5?
Just let me check it, and it is very easy. See, did you calculate the number of moles of NaOH? Can you tell me number of moles of NaOH? What you have got?
Sir, 40?
Number of moles 40.
No, sir, sorry. 0.1.
0.1. Okay, see, number of moles of NaOH will have a formula. Given mass upon molar mass. What is the given mass? 80. And what is molar mass? 40. Yes or no?
Yes, sir.
So this will be cancelled. The mole is 2 moles, no? 2, 4 to 8. Now see, it's not empty. Number of moles of H2O, that is given mass upon molar mass. Given mass is 36 and molar mass is 18. And it is also 2 moles. Yes or no? Now, I'm going to apply the formula for mole fraction of NaOH, which will be equal to number of moles of NaOH upon number of moles of NaOH plus number of moles of H2O. Now, as you can see, number of moles of NaOH is 2 upon number of moles of NaOH 2 plus 2. So it will be 2 by 4. That means 1 by 2 mole fraction of NaOH. Mole fraction of H2O will be equal to number of moles of H2O upon number of moles of H2O plus number of moles of NaOH. If you are going to solve it, it will be again 2 upon 2 plus 2. That will be equal to 2 by 4 and it will be 1 by 2. So the mole fraction of each component will be half or 0.5. Let me know when you are done with this. Are you done with this?
Yes,
Yes.
sir.
Okay. Now the question can be asked in terms of weight by weight percent as well. Like it can be asked 46% weight by weight C2H5OH in aqueous solution. Calculate mole fraction of each component. You know what is aqueous solution means? What is aqueous solution? Sakina,
Yes, sir.
what does aqueous solution means?
Sir, in water, like liquid.
In water. Okay, very good. So you can easily write a sentence with this, and then I think you can do this. Please do it. Let me know if you are not able to do it.
Sir, will it be 0.46?
0.46 what? It's wrong. You are not able to do this. It's very easy. Whatever given in the question, focus on that. And what you need to calculate, focus on that. First of all, 46% weight by weight. What does it mean? It means 46 gram of solute. That means 46 gram of C2H5OH present in 100 gram solution. And you used 100 gram, right? 100 gram of solution. Now, this is your given. We need to calculate mole fraction of each component. There is two components. One is C2H5OH and another is H2O, right? Yes or no, Sakina?
Yes, sir.
So if you're going to calculate mole fraction of C2H5OH, it will be equal to number of moles of C2H5OH upon number of moles of C2H5OH again. And then another component is your H2O. So number of moles of H2O, right? So you can easily calculate number of moles of C2H5OH from here, and that is given mass 46 upon molar mass 46. That is 1, right? Yes or no? Please do respond. 1 upon 1 plus. Yes or no?
Yes. Yes, sir.
Now you need to calculate the mole of another component, that is number of moles of H2O, and it is given mass upon molar mass. What is the molar mass of H2O? That is 18. How you are going to calculate the mass of given mass of H2O? You know, this is the mass of solution, this is the mass of solution, and this is the mass of solute. So if you are going to subtract the mass of solution and mass of solute, then you will be getting 54, and this 54, 100 minus 46, this is your 54, which is mass of water. Yes or no? Please tell me. This is your given mass of water. So it will
Yes,
give
sir.
you 3 moles. It will give you 3 moles. So this is your number of moles of water. So you are going to put it here and you will be getting 1 by 4 mole fraction of C2H5OH. Now again, mole fraction of H2O will be equal to number of moles of H2O upon number of moles of H2O plus number of moles of C2H5OH. Now number of moles of H2O is 3, and number of moles of H2O is 3 plus 1, that is equal to 3 by 4 mole fraction. Please do write.
Sir, done.
Very good. Now see, always remember that if you are going to add individual mole fraction, you will be getting always one. You'll be getting always one. Just I'm gonna prove it. If you're going to apply the mole fraction formula here, it will be number of moles of A upon number of moles of A plus number of moles of B. If in this container A and B is present, A plus B, in which number of moles of A is Na and Nb. Then applying the formula for this, number of moles of B and then number of moles of A plus number of moles of B. Now, if you are going to take LCM, it will be Na plus Nb. And you can see in numerator, it will be Na plus Nb, and it will be cancelled and the value will be 1. So if you are going to sum all the uh, individual mole fraction, you will get 1.
Sir, done.
Done. Very. Now the another concentration term is molarity. Is molarity. Molarity is denoted by capital M, and I'm gonna define it. It is basically number of moles of solute per unit volume of volume of solution in liter per unit volume of solution in liter. So we can write it in mathematical form. That is, M will be equal to number of moles of solute upon volume of solution in liter. This is the formula for molarity. Now we will talk about its unit. So you know that in numerator there is moles, so it will be moles per liter, or either we can directly write capital M. Either we can directly write capital M. So please do write it. Let me know when you are done with this.